So we're only going to focus on the front side of the opener this morning. So the front side, we're just going to work on factoring each of the following numbers and then writing those prime factors out in standard form and then write them out in exponential form. We talked briefly yesterday about composite and prime numbers. A composite number has two or more factors, or more than two factors. A prime number only has two factors. So if you guys remember, a prime number, an example of a prime number would be 7. 7 only has two factors, meaning two numbers you can multiply together to get 7. It's only going to be 1 and 7. You can't multiply any other two numbers together to get 7, therefore making 7 a prime number. So when I ask you to factor 60 here, we're going to make a factor tree. So we have 60. You have to think of two factors of 60. Now remember, there are multiple factors of 60. For example, Rihanna could use 6 times 10, where Kelsey could use 2 times 30, where Brendan can use 3 times 20. It doesn't matter which factors you start off with. It matters that we all have the same prime factors at the end. So what two factors would you guys like me to use for 60? 6 and 10. All right, let's do 6 and 10. So then I come over to my 6 here. Is 6 a prime or a composite number? Composite, because it has more than two factors. So what two numbers can I multiply together to get 6?
2 and 3.
2 and 3. Now, 2 is considered a prime number, so I'm going to circle it. The reason why 2 is a prime number is because it only has two factors, 1 and 2. So if you take 1 times 2, you get 2. But you can't multiply anything else together to get the 2. That's why I circle it, it's prime. I look at my 3. What type of number is 3? Prime. So I'm going to circle that as well. That's my visual cue. I'm done with those numbers. I'm finished. Those are my prime numbers. So then I have to look over at my 10. I can factor 10. 10 is going to be a composite number. So what times what equals 10?
2 and 5.
So we have 2 and 5. Well, we already know 2 is a prime number because we identified 2 as a prime number with our 6. But what about 5? Prime. So I'm going to circle that one as well. Now, if you notice my factor tree, I don't have any more branches coming out of any of the numbers, do I? They're all a dead end. They're all circled. So those are the prime numbers. I'm then going to come up to the right of 60, put my equal sign, and I'm going to use those numbers and write them in standard form. Standard form means I put them in order from least to greatest. So I can't just put 2 times 3 times 2 times 5, because that's not in order. So if I'm going to put them in order from least to greatest, Darius, what would that look like?
2 times 2 times 3 times 5.
Okay. Bless you. Now you want to write it in exponential form. So I'm going to put another equal sign, and I'm going to write it in exponents. So I'm going to look, how many 2's do I have?
2.
So it's going to be 2 to the second power, or 2 squared, times 3 times 5. Now, I could put to the first power for each of these numbers, but it's not necessary. It's just extra writing. You won't be counted against it if you do, but you might as well keep it simple. Tissue? Yes. And then there's a trash can back by my desk and hand sanitizer on my desk as well. Any questions on that first one? Did anybody use 2 and 30? Or 3 and 20? No, we all use 6 and 10? Okay. Let's take a look at 45.
I didn't use 16, I used 5 and 9.
No, I was
Oh.
it took me a second, Isaiah. I'm like, wait, what? No, for 60 I was asking. So 45, the only factors you can use are what? 5 and 9. Because 45 only has how many factors altogether? Not 2, because that would mean it's prime. Well, 5 and 9 are a factor, right? Then what other numbers are a factor of 45? What number is a factor of every number? 1, and then the number 45 itself. So this one only has 4 factors. Okay, so let's look at our 5. What type of number is our 5? Prime, so I circle it. And what about our 9?
That's a composite.
So what times what equals 9?
This 33.
And 3's are what type of number?
Prime.
So we're going to circle them. All right, I have no more branches on my factor tree. I all come to a dead end. So I'm going to take these prime numbers and write them in standard form. What would this look like in standard form, Isaiah?
3 times 3 times 5.
And then to the right of that, I'm going to write it in exponential form. Nick, what would this look like in exponential form?
3 squared times 5.
Perfect. And box the whole entire thing. Any questions on those first two?
Now, how do you get the third?
We're getting there. All right, let's look at the next two. So Isaiah had a really good question. Well, now we're working with a larger number. The number is 128. Just using my math skills from earlier on, my multiplication, I don't know any small numbers that I can multiply together to quickly get 128. It's a larger number. So what I'm going to do is look and see, what does the 128 end with? An 8. An 8 is an even number, right? Every single even number is divisible by what number? 2. So I know that 2 is going to be a factor of 128. So I know 2 is one of the factors. Now, how do I find out what the other factor is going to be if I use 2? Yeah, you take 128 divided by 2, and you get 64. Okay. Now, in our previous problems, we've identified 2 as a prime number, so I'm going to circle that prime number. So now I'm going to come to 64. What are two factors of 64? Now, 64 has multiple factors, but what are two factors that you could come up with?
32.
32 and 2,
Or 8.
or 8 and 8. I'm going to use 8 and 8. If you use 32 and 2, stay with it, Rihanna. I want you to check your prime numbers against mine. Okay, so we decided to use 8 and 8 as our two factors here. Now, 8 is a composite number.
I think I did this wrong.
Okay, let me come back and I'll look and see where you're at. Try 2 and 32. 2.
Do I got this set up right?
Yeah, keep going. Yeah, keep going. So what are two factors of 8?
2 and 4.
2 and 4. 2 is a prime, so I'm going to circle it. But 4 is a composite. So how can I factor 4? 2 and 2. So if I'm looking at my factor tree here, I come to a dead end with that 8. But I look over to the right, I still have an 8 that hasn't been factored out. When you're dealing with larger numbers, don't get yourself lost and forget to factor every single composite number. So now I'm going to come to the 8, the other 8.
It's too long.
What are factors of 8?
2
2 and 4. Circle my prime of 2. And then I have to factor 4. What are my factors of 4? 2 and 2. And I'm going to circle them. Now, Rihanna had a really good comment there. It's too long. It's right. So it could get confusing when you go to write this in standard form. Well, the first thing that you guys need to notice here, what are all my prime factors? What number is it all? 2. So what I do, I go and I count every circled 2 that I have, since they're all the same. So how many do I have circled? 1, 2, 3, 4, 5, 6, 7. So when you go to write this in standard form, leave it how it is. Before you turn it in, I'll look at it and see why. So when you go to write it in standard form, you're going to write 2 times 2 times 2. You're going to make sure you have 7 2's there. So 2, 1, 2, 3, 4, 5, 6, 7. So there it is in standard form.
Ooh, can I? You happy?
What do you want to do?
The little 2 to the
So exponential form is going to be what, Jemiah?
2 to the 7th power.
2 to the 7th power. That's right. Nice job. So don't turn that in. I want to look and see why you got what you got. Okay? And then we'll fix it together. All right, let's look at the last one. This last one is a fairly big number. But I like numbers that all end in zeros because you can break it up pretty good. Rihanna, do you have a way that you can break this up?
Oh, I got 50 and 20.
Okay, so you use 50 and 20, which will work. So factor those. What's another way?
110.
Yeah, so what I would do,
I tried that.
I would take and look at my last 2 zeros. Well, if I have 2 zeros, I'm going to put a 1 and 2 zeros behind it. Then what am I left with? 10. But you could also use 2 and 500. there's many factors that you could use for 1,000. Does not matter which 2 you start off with. It only matters that you factor it out correctly. Oh, no, it took all of our stuff away. There, it's all back. Yay, good deal. Okay, so now let's factor 100. What times what equals 100?
50.
Okay, so we're going to do 20 and 5, or you could do 50 and 2. So 5 is prime. I'm going to circle it. Let's factor 20. 2 and 10. You could also use 4 and 5. 2 is a prime, so I'm going to circle it. So what number do I factor next?
10.
My 10 under my 20, right? So what is 10 factored?
5 and 2.
5 and 2 or 2 and 5. I always write my smaller numbers first. Now what number do I need to go to?
Yeah, 20.
The 10 that's up there by itself. So 10 factored is what?
5 and 2.
Not 5 and 5, because 5 and 5 would be 25. So 2 and 5 are prime, so I'm going to circle them. So now I'm going to come up to the right, and I'm going to put this in standard form. So how many 2's am I going to have to write out in standard form here?
3.
So I'm going to put 2 times 2 times 2, then what?
5.
How many 5's do I have? Oh, I do have 3. All right? And then exponential form, it's going to be written as, how many 2's do I have?
3.
So 2 to the third, or 2 cubed, times
5.
5 cubed, or 5 to the third power. Nice job. Now, if you want to see if you have all the right prime factors, take your calculator and take 2 times 2 times 2 times 5 times 5 times 5, and you should end up with 1,000. Any questions? This is where we're going to stop on the opener today. The backside goes with the notes that we're going to take tomorrow.